Let's start with questions. Does anybody have questions from homeworks or other things they'd like to talk about before we get started? Close the door and give you guys a chance to look because I see people taking stuff out. These kids were loud back there. All right, last chance. Anybody with questions on things? Okie dokie. That's fine. So today we're going to be doing section 3 from chapter 4. So section 3 is another applications section. So there is one little piece of vocabulary, and then after that it's going to just basically be looking at some examples. The place where we're going to be looking at application on here in chapter 4, or in section 3 here, is going to be with navigation, like navigation problems. So the industry standard for navigation is that we talk about things in terms of bearings, or like a course. So for a bearing, or a course, what we're going to do is we're going to think about the compass. So north, east, south, and west. And we're going to start at north. And we're going to rotate clockwise. And that'll give us our terminal angle. Keep in mind for bearings and courses, everything is bounded between 0 and 360 degrees. So there's no negative bearings. There's no coterminal bearings. Everybody's cool? Okay. Let's just do a couple of examples here on taking a bearing and translating that into a standard position angle. Everybody cool with that plan? All right. So for my bearing, I'm going to do the bearing stuff in red, and I'll do the standard position stuff in like blue or something. We start on the north, and we rotate clockwise. So 58 degrees is going to be like to there. Everybody's cool with that? If I want a standard position angle, that starts on the positive x-axis and rotates counterclockwise. That'll put me to there. Everybody agree with that? What does that blue angle have to measure?
32.
Yeah, this has to be 90 minus 58 or 32 degrees. Everybody happy there? Let's do B. All right. We have, starting at north, 164. So rotate clockwise, that's 90 degrees to here. And then like 74 more to get me to 164. Is everybody cool there? Okay, to get to my standard position angle, I'm going to do 90, 90, 90, and then that much more. How much is that section there? $16, because it's 90 minus 74. So my standard position angle then is going to be 90 plus 90 plus 90 plus 16, or 288. Does that all look okay? All right, let's do 221 next. So again, north, so that's 90. Oops. That's 90. And then what, like 41 more degrees? So that's 90. That's 90. And then how much is that last section got to be?
49.
Yeah, 90 minus 41, which is 49 degrees. So my standard position angle then would be 90 plus 90 plus 49, which would be 229. Katie? Well, I'm sorry, what? Oh, yeah, thank you. Sure. Arithmetic. That's hard sometimes. And then my last one is 299, right? Okay, so here we go. 90, 180, 270, and a little bit more. 90, 90, 90, and then 29 more for 299. And then my standard position, oops, is 90, and then that much more. How much is that much? 61. And at this point, I'm going to stop writing in like how I got them. Because like, come on now, folks. Right? We're just finding complements. You know what I mean? Pretty easy so far, right? Converting a bearing to a standard position, not a big deal. The picture basically is all you need. And to draw the picture is just a little bit of common sense. You know? All right. So let's look at one of these navigation problems. So the first one I'm going to draw, or that I'm going to do, I'm going to draw a lot of stuff to kind of justify the process. And the second one will kind of streamline the process so it doesn't take like an entire sheet of paper and involve like a pretty intricate picture. But I just want to give you the heads up of what's going to happen here, okay? So the first one that we're going to do here, the picture is going to be a little bit intricate. There's going to be kind of a lot of work because I'm going to try to justify the process here a little bit. But once the process is kind of well established, we can we'll streamline it on the next problem and really show you guys all you really need to do. Does that sound okay? I'm just prepping you for like, don't get overloaded when we look at this the first time. Okay? All right. So it says a boat leaves a port and averages 40 knots. That's just boat language for nautical miles per hour. Traveling for 2 hours on a course of 215 degrees. Then the boat turns to a bearing of 162 degrees and travels for 55 knots for 3 hours. What is the distance and bearing of the boat relative to its starting position? Okay, so let's write down some information. In part 1, our speed is 40 knots. The time is 2 hours. And then my course is 215 degrees. In part 2 of my journey, the speed is 55 knots. The time is 3 hours. And the course is 162 degrees. Well, what do we ask for at the end is a distance and a bearing, right? Well, let's figure out the distance then for the first leg of our trip. If I'm going 40 nautical miles per hour for 2 hours, how far did I go? 80 nautical miles. Everybody agree with that? Similarly, if I went 55 nautical miles per hour for 3 hours, how far did I go? 165 nautical miles. So how far away are we from the port? $245, right? That's wrong. So if you're at your house and you walk like 3 miles to the east, and then 4 miles to the south. How far are you from your house? 5 miles. Not 7 miles. You're 5 miles from your house. Everybody agree with that? So it's not going to be just like add up the distances and we're done. Everybody's okay? All right, so let's think about what happened here. So I'm going to draw myself a picture. It's going to be kind of an involved picture to justify what it is that we're going to be doing. All right. So the first leg of my journey, I went 80 miles in the direction of 215 degrees. So we'll start by drawing that 215 degree angle. So starting at north, rotating clockwise, that's 90, that's 180, and then like 35 more. Everybody agreed with that? And now from that position, I'm going to draw that, put that arrow slightly different just so I can, there we go. It's a little bit easier for me if it, ends at a corner of my grid or whatever. I'm going to draw another XY axis. I'm going to draw the second leg of my journey where I'm going to go 162 degrees. So that's 90. And then like 72 more. I'll make that a little bit longer. Everybody's okay with that? So what I'm searching for is this piece, right? The length of that segment will give me the distance, and the bearing of that, and the angle of that would give me the bearing. Everybody agree? Okay. So here's going to be our plan. I want to figure out what that point to XY is. If I have that point, I can use the distance formula to calculate the length of that back to the origin. And I can use inverse trig functions to find the angle and build that out to get a bearing. Everybody's okay with that plan? So how am I going to do that? Well, I'm going to go this far over and this far down to get to this point x1, y1. Everybody agree with that? And then on the second leg of my journey, I'm really going this far over, call that x2, and then this far down, we'll call that y2. So what do I notice here? What does xy have to equal? Just x1 plus y1, or x1 plus x2, y1 plus y2. Does everybody agree with that? That's key to me. So, how am I going to figure out the values for x1 and y1? Well, if I look here, actually, let's pick a new color, right? I'll use orange. If I look here, what do I have? A right triangle. Do I know, and I know the length of the hypotenuse. How far was that? 80, right? Can I figure out this angle? Yeah, of course I can, right? What does it got to be? 55, right? 90 minus 35. See the red 35 there? Everybody's okay? I can then use right triangle trig to find the values for x1 and y1. What's the one hang up here? x1 and y1 are a point. What quadrant is that point in? Here's the xy axis. Here's x1, y1. What point, where, what quadrant is that in? Quadrant 3. What do I know about the coordinates in quadrant 3? They got to be negative. So if I'm doing it this way, I have to be really conscious about what quadrant I'm putting these things in, because I have to manually add the positives and negatives myself. I don't like that. Do you like that? No. Guess what we can do instead? Instead, I can just use my standard position angle to find it. So if my course was 215, what was my standard position angle going to be here? $90, $90, and then $55. Because cosine is x over r, right? That's how I can write that equation. Right? That was one of our definitions for sine, cosine. Tessa? I'm just pointing out to you that there was, on how I can find x1 and y1. Is like, look, here's a right triangle. We know the hypotenuse. We know an angle. That's enough to right triangle trig the sides. But that kind of stinks, because then we have to remember to make things positive and negative, and I'm going to forget. Right? You're going to forget, I'm going to forget, we're all going to forget. So instead of you doing right triangle trig with the orange triangle, let's use our point on the terminal side definition, where cosine is just going to be x over r, because we have the standard position angle. That was easy to get. We have r. That was basically given to us. So I can use that to find x. No, we did not. again, remember, this first example is just me justifying the process we're going to use. In the second example, we'll streamline things and it'll become like, oh, all I need to do is remember like these three formulas and then just be done. That's where we're going. So like just kind of hang with me and try to understand what's going on the first one, and then we'll streamline this and it'll become much simpler on the second one, I promise. Everybody's okay with that? So look at what this formula boils down to. The x, define the x. We're using cosine. On the unit circle, what is cosine? X. Oh, that should be easy to remember. And what's the 80? That's just the distance we traveled, right? Oh, and the 235 was just the standard position angle equivalent to my bearing. And then the y, define the y, what are we using? Sine, because on the unit circle, sine is y. Oh, that's lovely. Isn't it nice when it's intuitive and things go together and make sense? Define the x2 and y2. Guess what we're going to do? The exact same thing. So I need this angle here, right? 90 plus 90 plus 18. So that's 288. So x2 is just going to be 165. That was the distance traveled. Cosine 288. And y2 is going to be 165 sine 288. So if I go to my calculator, make sure that I'm in degrees, and I'm going to do 80 times cosine 235 plus 165 cosine 288. That's my x. And then I'm going to have, oh, just do it that way. 80 sine 235 plus 165 sine 235. And there's my y. So that's the point 510 negative 22246. So remember what we're looking for in the problem. We're looking for the distance from the origin, right? The origin here. And then the distances to that point. How can I calculate the distance between 2 points? The distance formula. One of the points, though, is the origin, 0, 0. So really, what is the distance turning into? Just the square root of x squared plus y squared. So I'll go to my calculator, square root 510 squared plus, put in parentheses, answer previous squared. And I get 222.51-ish. There's my distance. What was the other piece that it asked for, though? Also wanted the bearing. Is this going to be a long, drawn-out process to get the bearing? No way, man. Not a big deal. All I'm going to do is I'm going to plot my point xy. So I'm going to go 5 over and like negative 200 down. So I'm looking for this angle, right? So that part's 90. What is this part here? An angle between the terminal side and the x-axis, we call that phi. So my bearing is just going to be 90 plus this phi. How am I going to calculate phi? Well, I know x and y, so I'm going to do tan inverse of the absolute value of y over x. Am I going to do that like every time to find my phi? Yeah, man, every time. Because I'm always going to have an x and y. I'm always going to need to find a phi. Just always going to use tan inverse. Always going to use the absolute value. Yeah, because the 90 was coming from this piece. You know, sometimes you might be adding, sometimes you might be subtracting, just like the previous problems that we had done. So it's just like a worksheet 2 problem, basically. All right, so 90 plus tangent inverse. I'll go grab the absolute value of y divided by x. I get 178.7 or 68 or whatever you want to round it to. Pierce.
How do you get the degrees? Like, how do you have like 90 plus and then
The phi?
Yeah, how do you know what that is?
How do I know what 90 is?
No, the cube.
The phi?
That.
Well, it's here in my picture. It's that angle formed between the positive x-axis and the terminal side, right? I'm just looking for that angle. Okay? So to do that, I'm just going to be doing tan inverse of the absolute value y over x. Because I know that if I'm using a point on the terminal side of my angle definition, tangent is y over x. I have an x and a y. And because it's a phi, not like an standard position angle I'm finding, that's why I put the absolute value in it. Is that okay? So the same reason why we're using absolute values in worksheet 2 the whole way through, because again, we're finding a phi, not like a standard position angle. And we're done. So let's do another example, and we'll strip this down and streamline this process to where it feels like I don't need to take an entire sheet of paper to do one of these problems. Yeah, because you're always going to have an X and a Y. Yes, it'll always be tan. To find your phi, you'll always be doing the tan inverse of the absolute value of y over x. All right. Here it says a plane can fly or can travel 525 miles per hour under its own power. If a pilot flies at a plane's maximum speed on a bearing of 125 degrees, and there's a 35 mile per hour wind traveling at a 200 degree bearing, what is the plane's actual speed and bearing? Okay. So the speed for the plane, 525 miles per hour. Bearing for the plane, actually, let's write it this way. Is 125. My wind, the speed for the wind is 35 miles per hour. The bearing for the wind was 200 degrees. Now, what's different about what I'm given in this problem versus the previous problem? What didn't they give me in this problem that they did give me in the previous one? Times, right? Right? They told me some times. Does it matter that I didn't get any times here? Because what are they asking for? Speed and bearing, not distance. So I don't give a hoot how long the plane's been flying wherever. Does not matter to me. Everybody's cool? Okay. So my first order of business is going to be to translate these bearings into standard position angles. So from the north, we go 90 and then like 30 more or 35 more. So my standard position angle is going to be 90 plus 90 plus 90 plus 55. So that's 325. Everybody's okay with that? The SP is for standard position, the P is for the plane. Just so I don't confuse myself. I'll do the same thing for the wind then. So 90, 180, and like 20 more. So my standard position angle is 90, 90, and then 70. So what's that? 250. God bless you. Everybody okay with what I did here? Notice I'm not even going to bother drawing the big complicated picture because I don't need it. All I needed the big complicated picture for was so that I could justify that the xy that I'm looking for is going to be x1 plus x2, y1 plus y2. How am I going to calculate x1? 525 cosine 325. How am I going to calculate y1? 525 sine 325. How am I gonna, well, let's call that XP and YP, right? Keep the subscripts constant. So how am I gonna do XW and YW? $35 cosine 250, and then 35 sine 250. So my xy is just going to be x1 plus x2, y1 plus y2. So bust out my calculator and do that. Look at how fast we got to this point. While it's still kind of a lot of stuff, it's much less than it was before, right? We're already figuring out that x and y. So 41808, comma, negative 33402. 41808. Think. Oh, 334. Questions? Tessa? You're doing a lot of mumbling back there under your breath. Is it okay? The only reason I drew it was to justify this relationship. Once I drew the picture once, I can see that that's going to be what I have to do every single time. So why draw the picture over and over again? It's such a headache. It took up a bunch of space. It didn't really help me once I had this relationship. That's all I needed. So how do I calculate the distance then? Same way we did before. Square root. Oh, Boise. What just happened? $535.13. And again, these speeds were in miles per hour, so this speed will be in miles per hour. Just like we did before. Exact same process. And then my bearing, gonna plot my XY. So I go 41808 over and negative 334 down. So that's my bearing. So my bearing should be 90 plus phi. So that's going to be 90 plus tan inverse of the absolute value, y over x. We'll just go to our calculator. 90 plus tan inverse math number absolute value y over x, and I get 128.62. And I'm done. That went much faster than before, right? So what am I really remembering? Here, there's like just a handful of things that I'm using. Like x sub whatever is I'm going to just use I'll just write distance here, but it could be speed or whatever. Oops. Right? Just how to calculate those x1, y1, x1, x2, y1, y2 components. Right? But that's pretty easy. I have to remember that xy is just going to be the sum of the two that my total distance is just that, and then my phi is always going to be that. But that's what it basically boils down to, is I just need to grind through those couple of calculations and I basically get my answer, right? Does that help streamline things enough for us? That's not too bad, considering where we started at, right? We started, that was awful. Okay. One more example. What do you guys think? Something different happens. It's not a big deal. This should be something where we can pick up the difference just on reading comprehension. But it's worth looking at. We won't go all the way to the finish on it. We'll just point out to you guys what the difference is and how that changes things. So here it says a plane can travel 480 miles per hour under its own power. The pilot sets a bearing of 320 degrees. As the plane travels, the pilot notes the plane is actually traveling at a bearing of 325 degrees at 472 miles an hour. What is the bearing and direction of the wind? What's going on here that's different than before? So last time we did this, right? What are we given in this problem? So we have some plane stuff, right? And then what's this other part that we're given? Isn't that the total? Right? That's what actually happens after the wind hits it. We're looking for the bearing and direction of the wind. So what do I need to do to these equations? I need to rearrange them so the wind is by itself, right? Everybody's okay with that? How am I going to find x total and xp, y total and yp? Same way we did in the previous problem, right? But to find xw, yw, that's going to be x total minus xp, comma, y total minus yp. But from there, everything else is identical. So all that happened in this problem was, instead of giving the two components that give you the total that you add, you're given the total on one of the components, so you subtract to find the third component, or the second component. You know what I mean? That's it. I'm not going to grind through all the numeric details here, because this is the piece catching that it's a subtraction problem rather than addition problem. That's the hard part. But that's just reading comprehension. And once you've seen it and heard what it sounds like, you probably will catch it the next time it pops up. What do you guys think? That's okay? You glad we did just that much of it without grinding through the whole thing? That feels like enough, right? It's a lot of numbers at 2:20 on a Friday. All right. At this point, you guys can now do 24 through 31. And worksheet 7. Is that due this weekend? Of course not. It's not due on the 16th either, Mr. Gulick. So what is due this weekend? Should we talk about that? Maybe just once real quick, right? So you guys should have, for me, this weekend, we should be able to have up through, what is, it's the 30th, right? Is Sunday? Okay. So you guys should have 1 through 23, and then worksheets 1, 2, 3, and 4. Yikes. Next week, yeah, Katie? Of course. Next week we'll spend a day in class working through some of these story problems that we just did. So don't feel like you necessarily have to do all of 24 through 31 and worksheet 7 all on your own this weekend. We'll take some time in class, at least part of the day on Tuesday, and do some of that.
Which one?
Huh?
Which one?
The stuff that's due on the 6th.
Oh.
Thursday will be our review day. And then you guys, I guess the following Monday will be the test. Does that sound okay? All right. That's it for me today. What do you guys think?
Pretty alright.
Pretty all right. Yes, sir.